Good morning and welcome to Algebra 1. Today we're going to go over the worksheet and then we're going to talk about how we graph piecewise functions. First, the questions on the piecewise function worksheet basically gave you the function to go to, and then the input told you which equation to use. So I'm not going to do all of them. I'll give you all the answers, but we're going to pick and choose a couple. So starting at number 1, the answer is negative 4.5. Number 2 is 1. Number 3 is negative 16. Number 4 is 0. Number 5 is negative 2. Number 6 is 6. Number 7 is negative 1.5. And number 8 is negative 5. So let's pick and choose a little bit, not much. Let's do number 6 first. Number 6 is h of negative 5. So the question asks you to look at the h function first of all. The input is negative 5. So is that an x value that's less than negative 4, or is it greater than or equal to negative 4? Negative 5 is more negative than negative 4. So it's less than negative 4. So we're using negative x plus 1. So we're going to plug in the negative 5 in place of the x. Negative 5 is 5, and 5 plus 1 equals 6. So h of negative 5 equals 6. Let's also try, let's say, number 3. Because I think I talked to everyone about number 1 already, but we could do, no, let's do both. Number 1 answer. Number 1 says f of negative 3. So we're going to use the f function, obviously. The question is negative 3 less than or equal to negative 5 or greater than negative 5? Negative 3 is less negative than negative 5, so it's greater than negative 5. So we're going to use the second equation from that list, which is 1/2 x minus 3. So it's 1/2 of negative 3 minus 3, which is negative 1.5, minus 3, which is negative 4.5. So f of negative 3 equals negative 4.5. Choosing the correct equation obviously is very important. Be careful when they are negative, because you have to remember that a negative number becomes smaller the larger its absolute value becomes. So negative 105 is much smaller than negative 2. Keep it in mind. And we could also do number 10. Number 10 is not there. I meant number 3, which is f of negative 10. I knew there was a reason why I had 10 in my head. Negative 10 is obviously a smaller number than negative 5. So we're using the f function again, but this time it's the other equation. Since negative 10 is smaller than negative 5, we're going to use the 2x plus 4 equation. We're going to plug in negative 10, and we're going to solve for negative 20 plus 4, which is negative 16. So f of negative 10 equals negative 16. The other ones are done just the same way. Make sure you choose the correct equation based upon where the x value falls within the domain. That's why we list the domain where we do. Okay? Now, the homework's going to be to graph on the bottom section, but let's talk about how first. So in order to tell you how, what I'd like to do is bring up some coordinate grid paper. And I'm just going to put on this grid a piecewise function. So I'm just going to write it over here, and hopefully you can read it. Whoops, that's not what I want to do at all. I want to make sure that I have the markup tool, and now we can do it. So I'm going to write down the function I want you to graph, which is f of x equals, and then the squiggly bracket thing, x plus 1 on the interval of negative 3 less than or equal to x less than 0, and negative 2x minus 3 on the interval of 0 less than or equal to x less than or equal to 2, and 4 on the interval x greater than 2. So take a moment, write down the piecewise function if you have to go back and listen to me as I wrote it down, because it might be hard to see through the grid lines, I understand. But now that we know what we're looking at, let's try to graph it appropriately. Here's how we graph a piecewise function. We know that there are 3 sections, so we're going to just handle it one bit at a time. The first section occurs from -3 to 0. All right? So the question is, well, what are the outputs at -3 and at 0? I have to know where that segment goes. So at -3, what I'm going to do is I'm going to take the actual equation, which is x plus 1, and I'm going to plug in -3. So -3 plus 1 is -2, which means when the input is -3, the output is -2. So at -3, -2, I'm going to put a dot. Now, because the domain says it could equal there, it's a closed dot. So -3, -2 gets a closed dot. You can always print some graph paper so that you can graph it as well. But there's also the end point, the 0. So I have to plug it in again to figure out what happens when I plug in the number 0. So it's again x plus 1, but what happens at 0? Well, 0 plus 1 is 1. So when I plug in a 0, I got out a 1. So 0, 1. Now it doesn't say or equal, so it's an open dot at 0, 1. And because it begins and ends, it has no arrowheads, I'm just going to connect those 2 dots with as straight a line as I can manage. Good. Now we're going to move on to the next piece. So I have more room to do the math. I'm just going to clear this part of it and continue with the next piece. -2x minus 3, that's the equation I'm going to be working with. Now it has a start point at x of 0 and it ends at x of 2. So I'm going to do the same thing I did just now. I'm going to plug in where it begins and also where it ends to find the 2 coordinates. 0 first, -2 times 0 minus 3, and that is -3. So the coordinate is 0, -3. It's a closed dot because it says or equals. So at 0, -3, I'm going to have my closed dot. I also have to find out what happens at 2. So I'm going to plug in the number 2. So it's -2 x minus 3. I'm going to plug it in. So -2 times 2 minus 3, which is -4, minus 3, which is -7. So when I plugged in a 2, I got an output of -7. So at +2, I'm at -7 down here. Now is it closed or open? It's closed because it says or equals. And now I'm going to connect those 2 dots with a straight line. And that's the first 2 segments of my piecewise function. I'm going to erase what I've done for work and then continue to the very last piece. Well, the very last piece is pretty simple because there's no x variable, which means when there's no x variable, the slope is 0. So it's a horizontal line that goes through 4 from an x value of 2 and beyond. So when x is 2, y is 4 with an open dot, and it continues horizontally forever. So there's an arrowhead there. And now I've graphed my piecewise function. One piece at a time. You use the domain restrictions, the intervals, as your inputs to figure out where to put your dots and connect accordingly. One piece at a time. Now, if I ask you to solve for f of 2.5, you could say by the graph, well, 2.5 is right there. I can see it's going to be 4. You can also look at the equations and say 2.5 is more than 2. The answer is going to be 4. What if I ask you for f of -1.4? Well, -1.4 is around about over here, so it's going to be, well, it's going to be hard to gauge. I don't know, like -0.3 3 or something? Well, let's use the equation this time. Negative 1.4 falls in the interval of negative 3 to 0. So it's x plus 1. So it's negative 1.4 plus 1, which is negative 0.4. So even without having the graph as an easy way to solve, we have the equations to plug it in and solve accordingly. That's how we graph from a piecewise function, and it's how we use a piecewise function to determine inputs and outputs. Okay? If you're asked what input will get you an output of, let's say, 1.5, let's just say. I want to know this time what input will get an output of negative 1.5. Well, now we're going to use the graph to find out where negative 1.5 is. So negative 1.5 is over here, and I can see that the only place it exists is right here. Now, which segment of my graph is this? Well, this is the segment that is going from negative 3 to 0. It's the first line, x plus 1. So what I want to do is say x plus 1 equals negative 1.5. Subtract 1 from both sides, and x equals negative 2.5. So negative 2.5 will get me an output of negative 1.5. We can use the piecewise function in multiple ways. You just got to be careful. So, your homework assignment is to finish the worksheet that you had for last night. The 3 graphs on the bottom ask you to graph the 3 piecewise functions on top. So please do that. Be very careful. Make sure you get your endpoints appropriate. Understand also that a piecewise function will never overlap itself. Even when you do have the same x value being used, one dot is open and one dot is closed. They will never overlap, and if they do, you graphed it wrong. Be careful and give it a shot. Tomorrow we'll talk about how to do it in our video and in class. Let me know if there's any questions or problems. Take your time with graphing. Be careful and log into the Google Meet if you have any questions. Have a great day.